seems like we coordinated because this will be the third talk on language kind of related things. So tiny bit about me, I'm CTO and co-founder at OSO. Before this, I did a PhD in cryptography and been using Rust for sort of like 5 odd years at this point. This is the OSO team from, or the team in the extended family from pre-COVID times when we could actually do this still. And okay, so what I'm going to talk to you about today is the software with the same name, OSO, which is a policy engine for authorization. And so what this looks like in your application, for example, so here we have some Python, is you would make a call to the library to say oso.isAllowed, and you pass in some parameters, and it'll basically return a true or false decision. And that's based on the policy, which is written in the Polar language, and that's the piece implemented in Rust. And so the syntax you see at the bottom here is the Polar language. And for example, we're saying here, like, specifying a rule which says, a user should be allowed to read an expense if the user's email matches the submitter of the expense. And kind of cool thing to call out here, right, is that the isAllowed call is just passing in the Python objects, and that's exactly the same things that these like type specializers are over. So this is actually checking that the user is a user object from Python, and expense is an expense object from Python, and the email field exists, the attribute exists on the user. All right, so we effectively designed OSO primarily to separate authorization code from business logic, but keeping the data where it is, right? So that's why we have the policy code, but it's like using the application objects directly. We wanted you to be able to like express authorization logic in as close to natural language as possible. But all of this is like as a library, which is kind of fully extensible from within your application. And so basically to achieve this, first and foremost, we built this Polar language in Rust. We then, we've written at this point 5 language libraries for OSO, and these keep growing. And these are all built on top of that like Rust core. And the cool thing of each of these is that they're using everything from those like host languages applications. So when I say host language, I'll mean like Python, Ruby, Java, things like that. So in this talk, basically, I'm just going to go through a little bit of the details from each of these sections and just kind of give you a taste for what's going on inside the code we wrote. All right, so this is like the current state of things. So you can see at the top is like the various language libraries we support for OSO. And underneath that is like the core Rust piece. So I'm going to kind of start from the bottom of this diagram and talk through some of the pieces. I won't really talk about the WASM stuff. That's for another time. There's enough to cover already. So the heart of this, the Polar language, it's a logic-based programming language. So if you're familiar with things like Prolog, it's based on that. So basically what happens when you write those like allow rules that we saw earlier, those get loaded into a knowledge base. So this, tracks things like constants we've defined or the various rules that we've written. And the sort of evaluation or the execution of this, right? So when you want to check, should this user be allowed to do this thing, you're actually making a query to that knowledge base. And so in Polar, the query is actually executes via a virtual machine. So when you make a query, it constructs this like one-off virtual machine, and it has a bunch of, it's got stacks for storing things like bound variables and the kind of current things it's executing. So in particular, so instead of like instructions that you might see in like a regular VM, this has goals, and these are sort of like the logic analog. So you can kind of think of query execution as like a search algorithm, basically. You're sort of trying different combinations of things to determine whether the conditions are true or not. So the kind of goal you get in this is like a backtrack, which is basically saying the current state I'm in is like incorrect, like this doesn't add up, so I need to go back to the previous conditional point and continue the search. The way the VM kind of gets like driven forwards is effectively you just continue popping off goals from this goal stack and like executing them. But importantly, the virtual machine can return these like query events from this loop. And so, so this query loop is generally executed through C API. So that's how we support it, Python, Ruby, and Java at this point is through the C API. And so this is kind of quite a simple API, right? You pass in a pointer to a query object defined on the Rust side, and you basically say, what's the next event? Like drive the VM forwards and give me the next event, which will come back as like a JSON string. So on the Python side, for example, this is what the OSO library looks like. So it's calling the inner FFI objects, getting the next event, deserializing the JSON, and then do the kind of things it needs to do. So going back to like the original example, right? So we had this like rule which would check if the email matched. Once it gets to that particular point where it says user.email, basically what's going to happen is the virtual machine will be like, all right, I need to do a lookup. So it returns back from the execution this query event lookup. So the virtual machine at this point is basically pausing and returning to Python to say, it's not, I'm waiting for you to do something. So Python does the kind of things it needs to. It's sort of like internally registers that it's doing a call. It'll use Python's getOuter method to look at the email attribute from that class or from the instance of the class. Calls that back into the virtual machine for like the appropriate call result, which so the virtual machine basically binds this value that was returned back to it. The string, for example, it'll bind it to a variable inside the VM, and then it continues, right? Or the Python code will tell it to continue, and it'll kind of go on its way. And so what's like really nice about this is because the virtual machine is kind of, it's all single threaded. There's no like background threads running. Once the VM is, you call into the VM, once it's finished, it returns to the host, and nothing else is happening. So in particular, right, when we did a bunch of different language integrations, so here is the same expense class in Python, Java, JavaScript, and Ruby. Even in Node, for example, you can call asynchronous methods, and it just handles them fine because it's on the Node side of things. Like we're not trying to write the Rust code, which can knows how to call the JavaScript functions in a certain way. It returns an event, and it's like a super, super easy model to allow you to write a bunch of different languages on top of Rust. And so the cool thing about this really is, and this is kind of coming back to the extensibility aspect I was talking about before, is the nice thing is when you're writing your authorization logic, you have the full power of your application available to you. You can call methods and class methods. You can write your own methods and types and all that kind of stuff, and use that straight from the policy. So I kind of briefly mentioned earlier that in Python, getAuthor is doing a lot of the sort of heavy lifting in terms of taking in a cached instance and looking up an attribute or a method on that instance. So we recently landed sort of we have an initial PR motion for Rust support, but Rust doesn't have anything like a getAuthor. Rust doesn't really even have runtime classes or anything like that. So in order to do the same kind of thing, I have some cached instance, I need to call some object, some attribute, some method on it. There's a bunch of different stuff we had to do. So again, I'm not going to try and go through all of this, but just give you a taste, right? So we had to define a class struct, which is kind of doing all the kinds of things that Python is going to do through types with you. So this keeps track of the attributes you expect to exist on the class, or on the Rust struct, for example, class methods that might exist, ways that you can check is this thing actually an instance or not. We to be able to make methods work, we had to define our own trait for methods, which could take in different arity methods, so different numbers of arguments into the method, and knows how to deal with converting these types between Polar and back to Rust and stuff like that. So what this ends up looking like, for example, this is the where we construct an instance method on a class from just a regular Rust method. We do a bunch of this wrapping. It's kind of the shim between Polar and the rest of Rust, where you can see there's a bunch of downcasting going on. So we can go from the fully generic any trait type to a concrete type, and converting things and that kind of stuff. And something I found particularly interesting about this, once I started engaging with this problem and working in it, I now see this cropping up in a ton of different places. So in particular, Rye and Rune, which is two sort of languages built on top of Rust, which allow you to pass in Rust types or methods. Funnily enough, they've both had to do very, very similar method traits and similar kinds of work where you upfront register a class and say all the things that are accessible on it. So that'll just give you a taste of kind of some of the things we're doing. Hopefully that was interesting. If you want to learn more around what the OSO product is itself, you can go see our website. We have a blog on there, which we're going to continue to put more stuff on Rust about that. There's the code repo, all of the the core of it, and all of the languages are all in the one repo. Or you can come chat to us directly in the Slack.